Hello, my name is Kritika Kumar and my teammates are Kanika, Ratika, Mahalakshmi and Meghna. Our topic is finding the shortest path using Dijkstra's algorithm. Dijkstra's algorithm is used to find the shortest path for a weighted graph. This is the question that has been given to us. Number 1 is the source and number 9 is the destination. First, at the initialization, what happens is that all nodes of the graph are put into a heap and the distance of the source node is set to be 0 and its parent is null. Whereas for all of the nodes, the distance is set to be infinity and their parents are also null. This is the initialization where distance and parent. The distance is 0 for the parent node, which is 1 here, and infinity for the rest of the nodes, which also have no parents. At the very first iteration, extract min gives you the node number 1. Nodes accessible from 1 are 2, 3, and 4. The distance of the second node is infinity, which is greater than 2, which is the weight of this edge. And hence, its distance is set to be 2 and its parent is 1. The next node that is accessible is 3. 3's distance is also infinity. Infinity is greater than 5. And hence, the distance is 5 and its parent is also 1. The next node is 4. 4's distance is currently infinity. Then, 4 infinity is greater than 2, which is the weight of this edge. Hence, distance is replaced by 2 and the parent is 1.
In iteration 2, we have to select the vertex which one has minimum distance in previous iteration. In iteration 1, the vertex 2 has the minimum distance. So, I extracted from the heap neighbor vertices of 2 are 5 and 3. Now check the distance of 5 and 3. The distance of 5 is infinite. The distance of 3 is 3. 3 is 5. We are adding up the distance between 5 and 2 and the distance of 2. Now the distance of 5 is 3. Infinite is greater than 3. So we have to change the distance of 5 from infinite to 3. Similarly, we have to check the distance of 3. That is, the distance of 3 is already 5. 5 doesn't greater than 5, so we can't change it. In iteration 3, the vertex 4 has the minimum distance, so it is extracted from heap. The neighbor vertices of 4 are 7 and 3. The distance of 7 is infinite. We add up the distance between 4 and 7. And the distance of 4 and check infinite is greater than 4, so we have to modify the distance of 7 from infinite to 4. So similarly, we have to check the distance of 3. The distance of 3 is already 5. 5 doesn't greater than 5, so we can't change it.
For the fourth iteration, vertex 5 has minimum distance. So it is extracted from heap. Its neighbors are 2, 3 and 9. We can't take 2 since it is not in heap. To calculate distance of 3, we add up the distance of 5 plus weight between 5 and 3, which is 1. After adding up, we'll get 4. Since 4 is less than 5, distance of 3 becomes 4 and parent is 5. Similarly, for distance of 9, we add up the distance of 5 plus weight between 5 and 9, which is 7. After adding up, we'll get 10. Since 10 is less than infinity, distance of 9 becomes 10 and parent is 5. For the fifth iteration, vertex 3 has minimum distance, so it is extracted from heap. Its neighbors are 1, 2, 4, 5, 6, 8. Since 1, 2, 4, 5 are not in heap, we take vertex 6 and 8. To calculate distance of 6, we add up the distance of 3 plus weight of 3 and 6. After adding up, we'll get 5. Since 5 is less than infinity, distance of 6 becomes 5. Parent is 3. Similarly, for vertex 8, distance and the weight are added. After adding up, we'll get 5. Since 5 is less than infinity, distance of 8 is 5 and parent is 3.
So before going to iteration 6, we just need to see the smallest value in iteration 5. The smallest value is 4, that belongs to the node 7. So from 7, it goes to both 4 and 6. From 7 to 4, the distance is 2. And then the value of 7 from table is 4. And then the value of 4 from table is 2. The 2 should be greater than 2 plus 4. But here the 2 is not greater than 6, so the condition becomes false here. So then from 7 to 6, the distance is 2, and then the value of 7 from table is 4, and then the value of 6 from table is 5. Here also 5 is not greater than 6. Here also the condition becomes false. So there are no changes in the iteration 6. So we can move to the iteration 7. So in iteration 7, before going to iteration 7, we just need to check the iteration 6. The smallest value is number 5. It belongs to the node 6. From node 6, it goes to 3 and then 7 and then 8. Here the 6 to 3 distance is 3. The value of 6 from table is 5. The value of 3 from table is 4. Here the 4 must be greater than 3 plus 5. But here the 4 is less than 8, so the condition becomes false. Then from 6 to 7, distance is 7. The value of 6 from table is 5. The value of 7 from table is 4. The 4 must be greater than 7 plus 5, but the condition becomes false. Then from 6 to 8, the distance is 8, and then the value of 6 from table is 5. The value of 8 from table is 5. Here also the condition fails since 5 is less than 13. So there are no changes in iteration 7 also.
Takes 8 tables are 3, 6, 9. 3 and 6 are completed. Now we are going to see 8 and 9 vertices. Its weightage is 1. Vertex 8 weightage is 5. Add 1 to it and become 6. 9 parent is 8. Vertex 8 is completed. Now we are going to 9th iteration. Vertex 9's neighbors are 5 and 8. 5 and 8 are completed. This condition is false. Thank you.